Morning students. In the previous lecture we are discussing with what is electric motor, the construction of electric motor and the principle of electric motor. That is, when a current is passing through a wire, it experiences a magnetic force. Okay, now in this lecture we discuss with the working of electric motor. What is working of electric motor? As you know that in motor, a rectangular coil means armature is placed in a magnetic field with the help of magnets. When the current is passed through the coil with the help of battery or source of current, then it experiences a force and rotates about the axle. Okay, so in details, when a current I is passing through rectangular coil ABCD, this is also known as armature. A current I is passing through rectangular coil. Two equal and opposite forces, F1 is vertically upward and F2 is vertically downward, acts on arm AB and CD respectively. Okay, now from this diagram you can see that F1 is acting on a line, F2 is acting on a line, but these lines are different, and if the forces acts in such a way that they are at different lines, then this rotates anti-clockwise and this rotates clockwise. This means the system rotates. Okay, so since the line of action of these forces means F1 and F2 is different, so the coil ABCD rotates. Okay, about the axle. After half rotation, as you can see, CD reaches at the position of AB. Okay, so the direction of current is reversed in arm AB and CD, because after half rotation CD is at the position of AB and AB is at the position of CD. Okay, so forces F1 and F2 acts in same direction, but now they are at AB and CD because their positions are interchanged, and the coil ABCD rotates continuously without changing direction till the current is passing. Okay, now a new topic, electromagnetic induction. What is electromagnetic induction? This is the phenomena of inducing. This is not conducting, this is inducing. In conducting there is actual contact, but in inducing there is no actual contact. Okay, so the phenomena of inducing an electric current due to the change in magnetic field. Once again, the phenomena of inducing an electric current due to the change in magnetic field is called electromagnetic induction. In short form, EMI, electromagnetic induction. Okay, this is discovered by Michael Faraday. Okay, this is discovered by Faraday with the help of 3 experiments. Okay, so here we discuss only 2 experiments because the experiment third is also we do with the help of experiment 2. So the first experiment is when a bar magnet is moving towards or away from a coil connected to galvanometer. This is galvanometer. But what is galvanometer? Galvanometer detects current in an electric circuit. It detects a very small current in circuit. So we use galvanometer. So a galvanometer shows deflection due to the presence of current. Once again, when a bar magnet is moving towards or away from a coil connected to galvanometer, galvanometer shows deflection due to the presence of current. This is the first experiment. The same observation we will get when the bar magnet is fixed but this coil is moving towards or away from the bar magnet. Okay. Now the experiment number 2 is the same observation as in experiment 1. Means the galvanometer shows deflection we will get when a current carrying coil is moving towards or away from the coil connected to galvanometer. In this experiment, the bar magnet is replaced by a current carrying coil or current carrying solenoid. Okay, because the magnetic field of bar magnet and solenoid is similar, so we get the same observation as in experiment 1. This means galvanometer shows deflection when the current carrying coil moving towards or away from the coil connected to galvanometer. Okay, the same observation we will get if this coil is fixed and this is moving towards or away. Okay, now the third experiment. In third experiment we introduce a key in current carrying coil. With the help of key we change the current. Due to this, magnetic field linked with coil connected to galvanometer changes. Due to the change in current, magnetic field changes and the galvanometer shows deflection. So that only difference in experiment 2 and experiment 3. In experiment 3 we have a key connected to the coil in which current is passing. Okay. Now the conclusion of these experiments is when magnetic field through the coil changes due to the presence of bar magnet, due to the presence of a current carrying coil or solenoid, an electric current is induced in the coil which is connected to galvanometer, that shows deflection in galvanometer because current is flowing, current is induced in the coil. So this shows deflection in galvanometer. This is the electromagnetic induction. In this case, the current is induced current, okay, and the potential is induced EMF. Okay, once again, here the current is induced current and potential is induced EMF. EMF means electromotive force. Okay. Now the Fleming right hand rule. Where we use this right hand rule? So the direction of induced current is given by Fleming right hand rule. Okay, right hand rule we use to find the direction of induced current. Okay, then what is right hand rule? It states that stretch out forefinger, middle finger and thumb of your right hand mutually perpendicular to each other, like this, mutually perpendicular to each other, like this. You can see this. This is thumb, this is forefinger and this is middle finger. Then if thumb represent the direction of motion, forefinger represent the direction of magnetic field, then the middle finger will represent the direction of induced current. Okay, thumb represent the direction of motion, forefinger represent the direction of magnetic field, the middle finger will represent the direction of induced current. Okay, the trick to learn Fleming right hand rule is F means force or motion, because the motion is in the direction of force, B magnetic field and I is induced current. So FBI, this is FBI. Okay, now the point to remember, magnetic field going into the plane of paper is represented by cross. Okay, and magnetic field emerging out of plane of paper represented by a dot. Okay,